Hello everyone. This is the video lecture for Pre-Calculus, Chapter 7.1, Trig Identities. So before we keep going, what is a trig identity? Well, look at this. So basically this came from the formula book, and it should be already in Blackboard. I can't remember what page it's on, but basically, there you go. Go looking through it. Eventually you'll find it's on the other side of the unit circle. So these are the identities. A lot of this is the basic stuff. It's still identities, but it's the stuff that we already have done and seen. In this first section in particular, we'll be focused on these Pythagorean identities. That'll come up a lot, so I'll be using those. It's kind of broken up that you'll see some of these in like the next section, and then you'll see some of those in the next section, and then the next. So this is how Chapter 7 is laid out. It's just in chunks, as you see here. Have this handy as we keep going through Chapter 7, because that way you can reference it at any time. Okay, what I'm going to do is I'm going to do a problem, and like if I use a different formula or some kind of formula that's a little bit weird at the time, then I'll like star it or I'll tell you. So this first section is super fast. I don't have very many problems for you here. So here we go. I got cosecant theta times tangent theta is equal to what? They want you to simplify. Now remember how I've always said in the past, in WebAssign you don't have to simplify, and that's very true. But in these particular questions, if you just go and retype the exact same thing, like if you type this in the answer box, you're technically correct because I mean, they're saying, what is this equal to? You can just retype it. You're technically correct, but they're not going to accept it, obviously, because it's not what they're going for. The program needs you to simplify to find what identity this is, kind of thing, okay? So you do need to simplify, not numerically necessarily, but certainly with the trig stuff that we're going to be doing. So how do we start simplifying? Well, I'm going to rewrite these guys in terms of sine and cosine that I know. So this guy is 1 over sine. Theta, I suppose, and this is sine over cosine. And notice if I have this, I can cancel my sines. So I got 1 over cosine. Now, would they accept this? I don't know, honestly. This is not something I would try personally because it's so close to the answer anyways. The answer here is going to be a secant. So this is my answer. I'm going to say that's my answer. Could you do this? Maybe. I don't know. You try it out, okay? I'm not, maybe it works for some, maybe not for others. I don't know. But secant is your answer. So this whole thing here is actually equal to secant. It's kind of funny because you're thinking, well, when is this going to ever happen? Why do I need to know this thing? Well, I mean, let's go back here. There's a whole ton of formulas that you might need to use. Who knows? We're just using the basics ones right here, just these guys. But it could happen at any problem. This also is preparing us a bit for calculus, where you're going to have to do derivatives and integrals, and doing derivatives and integrals of this thing is much harder than doing it just for this guy. So there's a point to simplifying, and basically is what we're doing. We're simplifying these guys. Secant x over cosecant x. What I do, again, if it's like the most basic way to simplify is to always break it down to sine and cosine. And so that's what I'm going to do here. That's 1 over cosine. Cosecant's 1 over sine. Well, this is a fraction. I can flip it into the numerator so that I get 1 over cosine. Now times sine over 1. Well, sine over the ones you don't need. Sine over cosine, if you recall, is simply a tangent. Now notice the difference here right quick. We had thetas, so you have to actually, type theta, or you can just type this, and if you push the A button, then it'll convert it over to this theta value real quick. So you can just type theta and it'll work. Here's just x. They will count off. They will say you're wrong if you're not using the correct letter. I know, it's silly. Well, there we go. 71010. I've got cosine squared theta times 1 plus tangent squared theta, and they want to simplify this guy. So I'm going to use a formula from this from the trig identities that I was showing you. It's one of the Pythagorean ones. We got secant squared theta equals 1 plus tangent squared theta. Notice that this guy right here is identical to this one here. Notice I said the word identical. That's identity. Yeah. They're the same. They're equal to one another. So I could just replace this. Well, if I want to, rewrite this in terms of sine and cosine, again, because it's normally that way, I'm going to do this. So that's 1 over cosine is what secant is. It's still squared. You can put the square in both top and bottom. It doesn't really matter. But notice that this is in the numerator. Technically, this is on the denominator. You cancel everything out, and you get a 1. Yep. So this whole thing right here actually just equals 1. There you go. 71016. 1 plus cotangent of A. Notice they're changing your letter again. They're just trying to get us, is what it is. They're trying to trick us. Divided by cosecant of A. Again, I want to replace this with sines and cosines. That's going to be the quickest road, the most default answer, I'd say. So cosine over sine for that guy. And this guy here is a 1 over sine. Okay. Well, I got this fraction. I'm going to flip it into the top. There are a couple ways you can solve this. I'm just going one direction here. So now when I multiply it, it's basically sine of A over 1. I'm going to distribute. You don't need that 1 anymore. So distribute to both of these terms. That means we got a sine A plus cosine A times sine A over sine A. And these guys cancel. So we got now sine A plus cosine A. And that's pretty simple to me. Next. So 71017. I've got cosine cubed x plus sine squared x times cosine x. They want to simplify this thing. Well, first off, I want to factor out one of these cosines to the front. Leaving behind a cosine squared x plus a sine squared x. This looks familiar to me right here. In fact, I'm going to show you the formula. It's cosine squared x plus sine squared x is equal to 1. That's the Pythagorean identity, one of them. And so I can actually just rewrite that as a 1, multiply by 1, and so therefore it's equal to cosine. So all that was just cosine the whole time. 71019. I've got cosecant squared x minus 1, all divided by cosecant squared. Now, I know you want to cancel, but you don't do that yet. We're going to cancel stuff. Just, you got to hold on a minute. Really, there's a couple ways that we can go about doing this. I'm looking at the method that I'm using here in front of me, and I'm wondering why I chose that method, because it seems kind of silly. So I want to go a different road than what I have here. If I mess up, then we'll go back. But hey, this is that lecture experience, right? I'm going to distribute the denominator. I want both of these to have that same denominator, common denominator, right? But I'm splitting it up. It's like I'm going common denominator backwards in a way, distributing my denominator to both of them. Well, notice these guys are going to cancel, right? They cancel, make a 1. And this is a flipped version. I mean, I could just jump to the answer, but I'm going to go slow here for you. This is 1 over a sine, right? And this is technically a fraction over a fraction. I'm going to take this and flip it into the top. And so what I actually have is sine x over 1 all squared, which I could just rewrite that a little bit nicer. This is pretty cool. That's very simplified, but it's not completely done. There's another Pythagorean, well, actually the original Pythagorean identity we just saw a second ago. This guy here, you can rearrange this one, this formula, to make it look like this. What if I move my sine over? So then I would have cosine squared x is equal to 1 minus sine squared x. Okay, this is just on the side. Okay, this is not my problem. I like equals. I got to keep going. But notice right here, this formula that I created, that's a copy paste. And so then I could just simply replace this here with cosine squared x. And there you go. That's it. So, like for notes, look that see that I got equals because it's literally equal. I mean, it's not just like a next step. It is literally equals, and that's good. But then sometimes I'm going to have to talk about it and stop. So just, I don't know how I'm going to always do that in my notes. You know, normally I just use a little star or something to kind of say, this is not the actual problem, but it's just me talking about it. 71089. So this one's strange. It just looked weird. So I got x divided by 1 minus, I'm sorry, the square root of 1 minus x squared. And they're saying that x is equal to sine theta. And they want to simplify this thing, like this guy right here. So first off, I just replace it with sine. Like wherever I see an x, I just put a sine. And that's squared, so sine squared. Well, notice this formula here. Didn't we just see that a second ago? So I can replace that inside with cosine squared. Notice that the square and the square root are going to cancel one another. And so you just got this guy. Well, sine over cosine is actually just a tangent. So there you go. That is all I have for that section. That is it. So the next sections will be more difficult, of course. But that, you know, just this is the style. Pull up your trig identity, see which one matches, see which one kind of makes, you know, a little bit of sense. If you got a sine squared, maybe there's a way to convert it over. If you got a cosecant squared, you know, that's what I'm looking for, something that looks similar to what you find in this page. All right. Thank you very much. Have a great day.